we were writing code for computers, all we would write in is ones and zeros. Why does there have to be a language? The language exists so that humans can interact with it, right?
Yes.
So let humans have the easiest time interacting with it and reading.
The following is a conversation with Zach Mueller in which we discuss how to learn to code at a really high level, what does clean code even mean, and what are some of the strategies and techniques that Hugging Face uses to make their numerous libraries work together. But we also discuss what I'm doing right now, which is recording this video, or what we do when we share our code. Why do we do this, and how it factors into our personal learning journeys. So I had a lot of fun. I learned a lot. We start off slow, but then we accelerate. I hope you enjoyed the show. Hello, everyone. So today in the virtual studio, we have with us one of the best deep learning software engineers in the world. I'm 100% convinced of that. And also an author of many popular courses, including the famous course, Walk with Fast AI, the one and only, Zach Mueller.
You're
Hello,
very kind,
Zach.
Radek.
No,
Hi.
it's all true. It's all true. I can't lie, so it's all true. And so, Zach, you work at Hugging Face. Is that right?
Yeah, I've been at Hugging Face now for just over 2 years. I think I hit my 2-year mark sometime in November. So yeah, about 2 years.
So, to many and to me as well, Hugging Face is a fascinating company from the outside. Like, I use your software essentially nearly on every project nowadays. And
Oh,
how does it feel on the inside? Is it good on the inside or?
it's good. Yeah. Everyone's very motivated and project oriented, which really helps with the whole let's ship it, get things done, get cool things going. Because if you look around, like all of your coworkers are just working on these super amazing projects and these new techniques and exploring everything. So you just want to get involved with that and do whatever you can.
And you're working on a super interesting project yourself on Accelerate, right?
Yes, I work on Accelerate, which, if you're not familiar with the project, it's a conglomerate of things. The core components is it's part of what helps run stable diffusion and those big models on your local GPUs by letting you offload big models into RAM. And the other side of that is we have a framework, Accelerate, that lets you run your training code device agnostic. So training on like a TPU and a GPU uses the same code at the end of the day, and it's not something like the trainer or FastAI's learner where it's wrapped around a bunch of code.
Yeah.
It's almost the exact same PyTorch code.
And it's absolutely crazy that you managed to run all of that on all those different platforms. Like, I find it quite impressive and quite crazy. But Zach, what I really would like to talk to you about is software engineering, software development, because
Yes, please.
so, so I often work with code written by researchers,
Hmm.
and some of that code is interesting, to say the
That
least.
that's one way you can put it.
One way, well, yeah, and to me, I find it quite like I don't understand the whole situation, because if you want to do well on a machine learning project, I would assume that you need some, I don't know, code clarity or legibility.
So I have a theory on that.
Hmm.
Um, for a bit of background, when I started this whole journey, it was when I was in college, majoring in software design. So my actual major is software design and development, and alongside that, I was learning FastAI, which is a very research-oriented library with how that framework is built, and it's there's certain decisions that are made there that you could see teetered across other researchers and how they try to think about things. And sort of the conclusion I've come with is researchers and engineers just need to make the model work.
Hmm.
Typically, like in a big company scenario, they're not the ones actually deploying everything. Their
Mhm.
job is just like build the model, get it going, check if this works, and that's it. And so they don't need to have the best code possible. And my other theory is in some cases, they don't have a lot of coding experience most of the time.
Mhm.
So either their coding experience comes from a language that doesn't make sense in Python, which leads to very obscure coding practices.
Mhm.
Um, there's some things in Java even where people that come from Java do certain things in Python. You're like, well, you don't have to do that here. It's nice that you are, but you don't have to do that. We handle memory allocation ourselves. Um, and so you have that side of it, and the other side of it is these people only have maybe like 1 or 2 years of coding experience, and then they're shoved into research because that's the research trick. Get you enough to
Mhm.
code and work with a framework, and then go do research. Well, you're not gonna learn how to be a really good practitioner if you're learning the basics over like 2 years.
Mhm.
Uh, my whole curriculum took like 4 years, and it was really double studying because I'm learning that curriculum and learning machine learning at the same time. Um, and I don't think that the job like needs it per se.
Mhm.
Like there's enough tools now where if you have a linter, right? So if you have something like rough and you maybe just write code comments, which is expecting a lot out of some people.
Yes.
In it's because researchers just want to go and shove everything
Yeah.
in a Jupyter notebook. But at least use a linter of some form, make your code readable, and at the end of the
Oh,
day, it's good enough, and that's kind of all that's needed for them.
yeah,
And that's not
possibly.
bad, I think. Um,
So, Zach, you're taking like a very kind approach to life, and I love it. You're like trying to understand what's going on there and sort of say, maybe that's okay. But you know, uh, to me, when I'm working on a machine learning project and it grows and grows, like I cannot do this thing where you write code once and then you cannot read it or modify it. I mean, I don't know. And I've seen research code bases and linter like that's also very kind because the research code I have dealt with in my past, like it was never close to a linter. Like the concept was completely But okay, so now that we sort of discussed our pet peeves with code in general, uh, Zach, to you, what does it mean, well-written code or legible code, or how would you think about that?
that's really good timing because we just had a study group that ended
Oh.
last week where
Uh-huh.
we went through a book called Software Design Philosophies. I don't
Interesting.
think I have a physical copy of the book here. I know I have it on my Kindle somewhere. But basically, we spent like almost 3 months reading this book and
Mhm.
kind of discovered actually Philosophy of Software Design by John Ousterhart, I believe is how you pronounce his name.
It's a great
And
book. A friend
oh, it's
recommended it to me, a while back, and I loved it. And there's also a great YouTube video by the author that a friend also recommended to me, and I loved it. So I understand that this is like a central piece for you, like a reference point when you think about clean code, right?
kind of, yeah. More so it was validating because
Valid.
the ideas that it talks about are ones that I agree with. Like, so if we're gonna define like a quote unquote clean, because that's debatable, readable code base generally should be documented. Throughout the idea of self-documenting, first of all. Self-documenting code is not documented. Documented means you have a doc string and your users expect to read the code how they should expect in their language. It's an oxymoron that doesn't work in the Python world. So it should be a very clear doc string. It should follow what generally the community would call cohesive practices, right?
Hmm.
So if you're coding in Python, code to the general Python community if you're expecting people to read your code. Same goes for Java, same goes for like Golang or whatever you're working with. And then always the code bases I love digging through are the ones that have tailored themselves with this knowledge, right? With this understanding of like we need to compartmentalize this code, make sure that if we have a class of like 1,000 lines, it makes sense why we do. Otherwise, we should split it up. The code is readable, easy to use, and then on top of that, like the resulting API isn't obscene. It's not convoluted. It's quick and easy to use. Like it. Those are what I would call like good code bases and good projects. Because while there is some say of go out, do your own thing, and explore new avenues, if you're wanting to build something that the community can get involved in and the community can use and the community can learn from, build it with the community in mind. We're not living in holes. It's open source for a reason. That's why open source exists. We can go look at their code and use the quote unquote what we call best practices everywhere. So that way, as a collective, we all have expectations of what we can expect with how this thing is written.
Wow, I love this. I love this. Thank you for that. I come from the Ruby world. Ruby.
And my dad worked intimately with Ruby.
Oh, interesting! Because it's a very interesting community and philosophy of writing software. And one of the guys there, DHH, I think it was him who popularizes the idea that you don't write code for the machine. You write code for the people who will read the code, for other human beings, and sort of, also, you write the code once, or maybe you modify it, you refactor it, right? But that's like a singular activity. But then the code can be read by, I don't know, 100 people, 1,000 people. In the case of transformers, I don't even know what high number of people, but extremely high.
So many.
So many. So you sort of, like you said, the emphasis on tailoring the code for the reader, for the code reader who might want to learn from it, who might want to modify it. That resonates with me very much so.
Yeah, I mean, like if you were, I'm trying to remember the other half of his quote because I know exactly the quote you're mentioning, and it's like if we were writing code for computers, all we would write in is ones and zeros. Why does there have to be a language? The language exists so that humans can interact with it, right?
Yes.
So let humans have the easiest time interacting with it and reading.
Very much so. And also what I discover myself is that sort of engineering time or engineer's time is fairly expensive. It's much easier to spin up another machine, even if you have code that is not perfectly optimized, than to spend more time on writing or refactoring that code. So we should try to maximize developers' productivity, even possibly at the cost. I'm not sure that applies to such a highly technical framework as Accelerate, where you want it to be also very performant, right? So maybe that's a different setting.
Yes and no. Like, people use Accelerate to train models. They get very upset whenever it trains slow, and it's a performance issue on our end. There is definitely a balance there. Like, I haven't really vocalized this publicly, but I'm not one that like uses Chat GPT. I just don't. Like, any of those code generation things I've never really used. However, since like beta, I have still used Copilot.
Yes.
Because I don't need like to automate everything. That's not what's going to make me efficient, especially with stuff like this where we have a huge code base. Well, huge is relative. Accelerate is quite tiny. Transformers is a bit bigger. Um, I don't need to, have an automated test schema, have, ChatGPT explain this code to me because it's small enough I know the code. What helps the most with me with that is using Copilot as sort of a drafting mechanism, right?
Hmm.
I don't ship anything Copilot writes. That's not what I do. But I look at like what it gives. Usually I'll use it for like filling out doc strings. Um, because it's really good at that.
Hmm.
And then based off of that, it saves me maybe 5 minutes, 1 minute to 5 minutes, but that adds up a lot. And that gives me
Yes,
more development time to sit there and think about the design and iterate
certainly.
and, sort of have this second mind of gearing me towards an idea. Yes, because it's Copilot,
Mhm.
it's going to give me some of what its code was designed around. Um, but it definitely makes that iterative process and coming up with different schema and deciding is this the right approach a lot easier.
I started using Copilot, and for that I had to switch to VS Code, and that was to a large extent thanks again to one of my friends. His name starts with a Z, ends with a AK. Maybe you know that guy, really good
No
guy.
idea who that is.
No idea. So for me, it has been a great experience to have the Copilot there when I code. And I've been writing a lot of Bash scripts recently,
Mhm.
and I don't know much about Bash, just the very basics, and this has been a terrific experience. So if I ever see my friend, I have to say thank you to him because he was the main driver behind me adopting VS Code. But yeah, so Zach, what would be some of the code smells that you encounter in code, that raise the alarm bells in your head?
Ooh, that's a really good question because I don't think I've ever had to verbally say that before. It's
Hmm.
it's gotten to a point where like I can generally just look at code and I kind of get a vibe off of it, if that
Hmm.
makes sense. Where I'll just look at it and be like, something's off here.
Sure.
It is literally that code smell that, in some ways happens over time where you can just sit there, look at a piece of code and not necessarily refactor it in your head. Your first
Hmm.
thought is, this seems a bit more complicated than we need
Hmm.
to.
So just to put
It,
this in perspective, I think you write code essentially every day. You spend your entire day in code. Like
yeah, that's
when we met, and it was the Fast AI conference, you were
oh
also
no.
coding like for half the day, uh, which is
I'm pretty sure somewhere there's a picture of me in, I think, a parka or something on my laptop while there's like Cheez Its next to me and the Fast AI lesson happening in the background. Yes.
yes, yes, yes.
Yeah, you
So
could say I
so
live in it.
so this is very different to the experience of like let's say a person like myself where sometimes I
Mhm.
might glue some piece of functionality together, or I can go for weeks without writing any like more involved Python code.
Mhm.
So that's probably how we have evolved this very intuitive understanding. Like, right, you've been doing this for so long. You keep reading so much code. You keep trying so many things. So you have this vibe, this feel. But if you were to put it in words, and maybe even like the one or two issues that immediately suggest that there's an issue with the code, what would that be?
So I actually just thought of the main one.
Hmm.
So when people think of code smell, what that generally means to me is if I walk away from the code for like 5 minutes and I come back, sit down, look at it. If it doesn't make exact perfect sense to me, something is wrong. You've done
Hmm.
something wrong because you should be able to come back to your code 5 minutes later that you just wrote and be able to have it all make sense. If it doesn't,
Hmm.
then that's code smell. That's something's not quite adding up. There's probably a simpler way that you can do things, and it'd be good to investigate. what? That'd be the
So,
first one.
mhm. So you're looking at code like a
Mhm.
person would look at a piece of writing. And
Yes.
again, this is something from the Ruby on Rails world because it's a very subjective feeling, but whether this paragraph conveys any meaning or the meaning that the author intended, and you being on the receiving end, you sort of look at it and maybe it needs to have some things rearranged. So what you're trying to optimize essentially is for the code to communicate what it's doing to you, right? So
Yes.
that you can step back. Mhm.
Yes, because like if the code is readable, no matter what, like even if it's not the best code, the most optimized code, but if the code is readable and easy enough to understand, I would take that any day over a hyper optimized solution that
Mhm.
is, you know, done in a way that's hard for me to read. Right?
Okay.
Because I can always now come back to this code and refactor it and keep that general idea because I've seen what it looks like before.
Mhm.
But going back to what we said, like code is meant to be read by people, right?
Mhm.
So that includes yourself. Make it easier for you to come back to because more than likely as a core developer, you're going to be the single individual the most that's going to be working with it. So, make your life easier. Just spend 20 seconds writing like four different variable names that are a bit longer or a bit clearer.
So be kind to yourself in the future. I love it. I love
Yes.
it. Yeah, like what would be the things that make code readable? You already mentioned good variable names, right?
Mhm.
Descriptive variable names. Uh,
So,
mhm.
yeah, there's a number of things you can do. Generally what's accepted is not having too many long lines, right? I There's some heuristic where it's like somewhere between 80 and 120 characters is the most optimized way for you to fit code on your screen and have a user be able to see all of it at once. Um,
Mhm.
Good doc strings, and I don't just mean like what it does, like go through the effort of define all the parameter names, define what it returns, define what they all do. If you find that too troublesome, there's a reason why I use VS Code. There is literally a plugin called Auto Docstring that will read
Uh-huh.
your function arguments and prepare the whole docstring how you need it. And it supports any
Mhm.
custom docstring format you want, not just like Google format or NumPy format. Um, spend just like 10 seconds, fill that out. Helps your users a lot. And then the other general guideline I've seen is if code is too complex and you can't make it simpler, put comments in the code. Like, and what the book talks about, and I agree with, just saying like above a for loop, iterating over X as a comment, that's not good, right?
Mhm.
That's not what I mean by comment your code, because we know that you're doing a for loop. That's very basic. But if you're doing like some complex math thing that has no other context except for in the math world of, single variable letter names where you have like X, A, B, Y, and whatnot, have a comment with the formula, have a comment with like the paper it came from. Give us
Mhm.
context because that is what comments are there for, to help the reader understand what's going on. Those are the main, when it comes to code, clear code. I can go on a documentation tangent if you want.
Sure. Yeah.
So, yeah, so the other half of that is like, how do you document, right?
Mhm.
Um, and people have been trying to answer that question in the research community with things like Quarto and like Pandoc and whatnot of how do you quickly turn like a Jupyter notebook into documentation and have
Mhm.
everything live off of that. The solution that we've sort of adopted at Hugging Face for most of our newer libraries is and Radek, you can probably put like a blurb here if you do video editing of like the name that I'm gonna find for you later of what this technique is called because it
Sure.
eludes me every single time. But basically,
Sure.
the idea is you separate your documentation into 4 areas. So you have your basic tutorials, you have your package references. So that's going to be just like raw API docs, just doc strings and what you got going on. And then the other 2 areas that are, I believe, critical is you have usage guides, right? So usage guides strictly talk about how do I use the thing. They don't bloat the user with here's what the thing is, here's what it's supposed to do, here's how it works. It is just there to go from A to B.
Hmm.
And then concept guides are where you can go talk about that, right? You can go talk
Hmm.
about, in the case of like Accelerate, there's something called gradient synchronization between like a bunch of GPUs at once whenever you're doing, and it's careful to keep an eye on when you're doing gradient accumulation. Well, a user just wants to know how to do multi GPU gradient accumulation. But over in the concept guide, I can go a bit more deep into the code and be like, well, hey, here's what Accelerate does for that. Here's why it does that. Here's the results of that. And so you're lowering like the barrier that a user needs to read when reading your docs, because if you have everything at once, that gets very complicated very quickly. And on
Yes.
top of that, you're keeping it focused on what they actually need, right?
Yes.
Because I can go look at the API docs, and then after I look at the API docs, I can go, okay, well, I see it has this thing. I want to know how to use this thing, and I want a bit more context than just like this example in the doc string. I go look at the concept guide. I don't want to be bloated with how does it work. I just want to know how. I just want to know what to do. So now I go learn what to do, and then maybe a few weeks down the line or a few months, then I can go, okay, well, I've been using this thing quite a lot. I should probably know what it's really doing. Let me go read the concept guide on it now. Um, and then they can get the full picture. You're not overloading the user. Your code is well documented because you've essentially documented the same thing 4 different ways, 3 really. And
Hmm.
now, after they've looked at all of that, if we've successfully done the previous parts, you now have a clean code base for them to go read and then go look at the code if they eventually want to like make a fix or put a PR in. So
Oh.
it's all these little things that when they come together, it just makes sense. And it shows because Accelerate, like before we did this switch to this new documentation format, we would get like community PRs every once in a while, and some could argue that like this is due to the popularity of Accelerate Rising and whatnot, and that's perfectly valid. But a lot of times, like in the last few releases, while we have been doing a lot of work, community PRs are a majority of the release notes. So by doing all of this, right, you enable the community to impact your library more. Your code is easier for you to read, and then it's easier for everyone to go and learn what's going on.
I love this.
It's small things that make a beautiful masterpiece.
I love this. And yes, I also forgot the name, but I'm familiar with what you're talking about, this separation. I will definitely link in the show notes below the video to material on that, because that's extremely valuable. And also the aspect that I wasn't fully aware of, where you sort of do this investment up front to make your library easy to modify and easy to understand by the community. Then in return, you get those PRs, right? Which, like Hugging Face employs quite a few people now, from what I understand, but still, it's just a tiny drop in the ocean of all the machine learning developers in the world, right? So if you can harness that power, some of it, to your project, that sounds fantastic.
Exactly. And like it's not a silver bullet, right? There are still issues that people have with some things that we do in Accelerate. There are a number of things that people don't necessarily like that we do in Transformers, but that's not necessarily the point. Like it's not going to be a perfect solution.
Hmm.
Um but it's enough to get you started where after you've played with it, you can tweak it to fit your needs. But I
Hmm.
firmly believe that setting yourself up with this, no matter what it ends up in, at least starting this way leads you on the path to success.
So, Zach, what are some of the ideas? Because there are so many concepts, so many repositories, uh, open source repositories by Hugging Face, right? We have like, I've lost count. There's so
Yes,
much of it now. But
so many.
you sort of, for many things, you want the pieces to talk to each other. Like if you do, parameter efficient fine tuning with transformers and whatnot, and there's accelerate in the background and all of that. So, what are some of the key concepts? Maybe there are some abstractions or ideas that you sort of try to incorporate into each and every library so that it is easy to modify, easy to extend, and
Sure,
or
I can
maybe easy
talk a
to
bit
use.
about transformers a bit and accelerate because
Yeah.
while I interact with diffusers, sometimes my experience with it isn't too close, and Peft and all of them is more Sorab, my other teammate. But the key guiding principle in accelerate is we do not allow magic. Period.
What is magic?
Which
I mean, I believe in
magic?
magic, but
um, yeah, some people might be kind of surprised by that as well because, like, the man who created it and used to work at Hugging Face, my former boss, Sylvan Guger, who wrote Fast AI, right? There's this idea of no magic means you're not allowed to have unclear code. You're not allowed to have code that does things in the background that is obscure, right? And
Mm.
so now we have a challenge of, well, okay, I want to do this cool thing. This cool thing is only like 3 lines of code is what I can get it to. And even I can go as far as getting it to 1 with the right abstractions. Well, now my argument is, okay, you can get it to 1 line of code. Is it easy for a user to follow what's happening? And that's like assuming internal. If it's an external API, like hooking into DeepSpeed or something, then all bets are mostly off. It's whatever DeepSpeed has. But at least coming from like us, if navigating what's happening as a concept is hard for the user, it's going to take some convincing to let us allow it. A very clear example of this is back in the day when I was working with Sylvan, we were trying to come up with a way to wrap around gradient accumulation. Because there's some things you have to do with distributed data parallelism for gradient accumulation to make it more efficient. And I came up with this 1 line solution, which is now in the library. It's accelerator.accumulate as a context manager that just does passive gradient accumulation. And when I presented it to Sylvan, he went, "This is fine, but it's very magical. You have a lot of things happening under the hood, and I don't like that."
Mhm.
And so I had to spend another week basically going, okay, well, I have this high level API. High level being like, it's a class and a function, and it does this super huge thing that a user doesn't need to know a lot of context to do. So I have this high level API. What's the equivalent low level API, where the user is just interacting with the code and it's at a very like line by line basis, almost them implementing what we're trying to do. And eventually I found this balance of implementing a low level API that the high level API can wrap around, and then wrote a concept doc around it, a usage guide around it, and everything was fine. Because while it was magic, right, technically it is magic. I magically do gradient accumulation, handle dividing the loss, handle gradient synchronization, all of that through this one context manager. The code and the trail it makes is clear enough to where you know what's happening as it's doing that, roughly. As close as I could
So,
get it.
so it's still this beautiful one-line API for the context manager.
Mm-hmm.
But when somebody pulls up the code after the 1 week of work, of extra work that you did, you sort of wrote it out in a way that the user can follow it. So it's sort of not magic anymore because
Yep.
things don't happen magically without the understanding of the user or Okay, love it. No, no magic.
Exactly.
That makes
And they
sense.
can literally choose between which of those APIs they want to do. They can do the magic one-liner and have their code be magical, or they can go the low-level version of that, still use Accelerate, still do everything it's doing, but have it be more clear.
And what about the config classes, like trainer config and all that stuff? I mean, they're quite big, I would say, at times.
Yes. So going to the transformer side, using data classes to store things kind of has become the standard.
Mm-hmm.
Um, and the reason for that is just because there's so many things happening in the trainer that you never want to overload a user with a humongous init docstring for a major class because
Mm-hmm.
it is overwhelming, right? You want it to be a simple API, but if they all of a sudden have to read through like 100 different things, oh my god, I don't know what to set right and I don't know what to set wrong. And you also can't just rely on quarks, right? Star star keyword arguments, because well now I got to go read this and this and this and this and this to figure out just what's going on.
Mm-hmm.
And so what they sort of decided over on the Transformers team is, well, okay, what if we just make configs? It's not perfect, right? You know, because now you're sitting there with like a B&B config, you have training arguments, and then that training arguments gets a bunch of configs too. But configs allow you sort of a scoped out version of what you want.
Mm-hmm.
And if you just leave it blank, usually it's got good defaults and you don't have to worry about it. Right. And so, yes, on the outside, it's like, well, there's 1.5 million configuration classes. What do I do with them all? But in my perspective, at least, it's split up in such a way where if you look into the config class, which you probably have a reason to do so in the first place, you can then learn and not be as overwhelmed because you're not sitting at 100 arguments, you're sitting at like maybe 10.
Okay, so to me, the way I understand it based on your description is again this no magic approach in some sense where you're hiding the complexity from the user. You're sort of, saying maybe we'll make our transformers code not that intimidating. There are only this couple of parameters that you need to care about. But if you want to do something more complex, go over here and you have the description there. So it's again not just some quarks that are floating around, but there's actually a point in the code base which you can find, where it is, and you can read up on what you can modify. All right, that makes a lot of sense. So one thing, and I'm not sure what your solution to this is at Hugging Face, but since you have so many repositories, so many libraries, and transformers depends on definitely accelerate. Uh, a lot of things depend on accelerate, but there's the path library as well, right, which also appears in various areas. So how do you modify one library without breaking the other library? How does that work?
Very carefully. Um, it's so before, whenever we were doing the trainer integration,
Mhm.
it it was rough, right? Because we're dealing with this super complex library that is literally used by millions of people every single day. And we need to make sure that we're doing it in such a way that doesn't break anything.
Mhm.
Now, the good news with that integration is, well, nothing breaks if all the tests pass. So we go with that assumption, right? Because Trainer has its own testing code base for that. It has its own tests written for the trainer.
So when you commit to accelerate, you run the tests from
Yep.
transformers.
Yep.
And
So
mhm.
we pull in transformers. We have integration CIs. Um, Typically, it's just the people that if something breaks, its help is needed immediately. and things that are likely to break if we did something. So like
So
right
wait,
now,
huh?
mhm,
Do
no,
you have it automated? Like it's
yeah,
part of some automated CI? Uh-huh.
yeah, it's an automated CI. So when you push something to main specifically, because it doesn't make sense to run those in like a pull request because it's just a lot of tests. But when
Mm-hmm.
you push to main, like it'll run the accelerate tests on GPUs, CPUs, and like single and multi GPU. And then it'll go run our integration tests, which test the trainer. It runs the trainer examples. And I believe we have one or two other libraries as well that it will go run their tests on. So if something breaks on our end, we know immediately that, okay, well, that broke something major. Let's go let Transformers team know. Say, hey, we merged this thing. It might take a day or two for us to fix it. Is it critical or not? No. Okay, we're going to skip the test for today because it'll be, done soon and you're not blocking any pull requests with the failing CI. That's typically what we do. So every day at about like midnight, we have a runner that'll go do all these things, report it back to us in a Slack channel, and then the whole company that wants to go and follow and keep an eye on how things are going can just go see, oh, okay, this failed. Let's go talk to some people.
Okay, so you don't have it, you don't run the test before you actually merge a PR into main. It's
So
run. Hmm.
we run the accelerate tests, right?
Yes.
We have a CI that does that, but no, not the integration tests.
Hmm. I would imagine that those tests, those integration tests, just because of the size of the library and it being deep
Mhm.
learning code, that this requires some powerful hardware and they run for quite a bit. Or did
Sometimes
you guys
it
sometimes?
depends. Because the thing with tests is if you, oh, who said it best? I forget who, but there's kind of a general rule of thumb of if your feedback loop is more than 5 seconds,
Yes.
that is not a good feedback loop. That is a
Yeah.
negative feedback loop. So now the
Yes.
question is, well, Transformers CI is a lot about like training models. Accelerate CI is a lot about training models. So how do you do that?
Yes.
Especially when you don't want to do it on like a GPU, it needs to be done on consumer hardware. So what we do a lot is tiny models and try and get 99.9% of our cases squared away in tests that take under 20 seconds.
Mm-hmm.
And then if they don't, they're shoved into what we call a slow runner, where that will just sit there for however long it needs to, run all the tests, and get our results back to us. Like in Accelerate, our merge CI runs in like 6 minutes, but
Wow.
then our daily CI takes like an hour.
That's still very good,
Yes.
based on my
Um,
experience with. And what you mentioned with the feedback loop, that's something that is extremely challenging to me working with machine learning code because, it's also very hard to be in a state of flow, right? When you have to wait for 10 minutes, let's say, for something to run. So this is what I loved about web development, that I would have all these Tmax panes open, and uh, essentially, if I change something in code, maybe the test for that piece of code will run and will report if it's green, yellow, or red or whatnot, and I could immediately see it on the other screen with the browser window what changed, and
mhm.
that was just such a good experience. I felt like I felt so much integrated into the whole process. But machine learning, it's just tough because of of how long stuff runs. So actually, a 6 minute CI for a library that brings so many pieces together, like Accelerate, that's just
Here,
insanely
let me
good.
see. Let me get you the actual number before I go saying magic things.
Well,
Let's
6 minutes
see.
or 10
Summary.
minutes, it doesn't matter as long as it's on this order of magnitude. Like,
Yeah,
um,
each one's about 10 minutes. 10 minutes total. Some of them are 6, but it's regardless, like a 10-minute feedback loop for all of the tests
Mhm.
across the entire code base is, I think fast enough.
Do you run them in parallel or sequentially?
Depends.
Mhm.
So what we tend to do, actually, yeah, it depends. PyTest lets you run them in sequential. Sometimes that works for some things. So we'll do PyTest like multi-runner things. My CPU yells at me, but it's fine.
Mhm.
Some things it doesn't quite work because when you do have tests that like need to push the limits of model memory, because you are like trying to do something big that allocates a ton of memory, running 4 of those at once is not going to work.
Mhm.
So we try and balance like, okay, where can we run multiple at a time and make that efficient? And then
Mhm.
where do we have to go one by one? And if we can't make that efficient, make sure the scope of that test is as small as possible so that we don't
Mhm.
have to do much, right? So we have training scripts where we'll iterate over just like 4 batches on a small model 10 times because we're testing various things, but it's a small enough model that it happens like in a few seconds. Um, but these are all, questions that you have to think about, especially if you're running a CI and it's on a hosted platform, every single second you pay for, right? Every
Mhm.
single second of GPU time you pay for. And even if you own the GPU, that is now energy that you're using instead, right? If you're, a hobbyist that's using like 4090s at this point, that's a very expensive electric bill. Um, and so taking this approach of like, well, how can I make my tests as efficient as possible, right? After making your code base as best as possible, um, is kind of a later priority that has a lot that you can do for it, but it the efficiency usually doesn't happen at first. Usually
Mhm.
at first you do have like 40-minute CI times. Accelerate had that for a while actually before finally it was like, well, okay, that's too long. Because you want to like test, what breaks, right? Your
Yes.
breakpoints should be what you test on. And if it's a big model and that big model trains for a long time to hit that breakpoint, kind of nothing you can do per se. Would be what
Certainly.
most people would think, but there are solutions around that.
Oh, yeah. No, that is the reality of working on software libraries. That sort of your quality of life depends on on your test suite, right? So spending some time on that is definitely justified. But Zach, like you said yourself, you live in code, like it's
Mhm.
your mind is there in the code base. You program for hours every day, and but what would you say that contributed to your improvement as a software developer most? Is it just the sheer number of hours, or maybe the books that you've read, or is it feedback that you received? What would you say?
Just building,
Just building.
literally. Like when I joined the Fast AI community, I was doing a lot of tinkering with code, right?
Hmm.
I was working out of Jupyter notebooks. I was just building things.
Hmm.
And when you build things and you try and do things, things break.
Hmm.
And when things break, that is either a frustration experience where you scream, yell, swear, and open an issue and then wait for hopefully them to look at it, or it's a learning opportunity where you
Hmm.
go, try and investigate it as much as you can, look into it, see what's going on, try and fix it yourself, and if not, like open an issue and now you can give them like more context besides just this thing broke, fix it please.
Hmm.
And as those little interactions grow over time, you start tweaking their, someone's open source code, some library workings code to do your needs. This sort of knowledge base and experience builds more and more. Like I'm probably well into the pretty sure I'm at least at 100 different repositories at this point, if not more. And it's
Hmm.
all just super small tweaks. They're not like super glorious projects. They're all super small things. My GitHub gists are probably even worse. Um, but just sitting in the code, tweaking it, like, oh, I have this idea today of it's not something flashy or anything. I just want to go understand like how this test works. Like these people are using this testing framework. All right, I'll make a super small test and like write and practice writing code and learn that thing. You reiterated how to write good code for yourself, and you also learned a concept. You know, it's a
Hmm.
win-win, and you spent like maybe a few hours learning how to do it and learning what to do and shoving the code on GitHub so that way it's there permanently. Do this enough times, you see enough code bases, you get a general feel for how things are. That's the most impactful one later in my career, I would say.
Hmm.
Um Early on, I was very lucky to have a professor at the University of West Florida called Dr. Brian Eddy, where I took his data structures and algorithms course. It almost made me cry. um, I can thoroughly remember myself and three of my other people in the class, my friends. We would rent out. They were all like in the cybersecurity club and the CS club, and so they had access to the study room where we host meetings. We would sit there over the weekend coding for like almost 72 hours straight, sleeping in there, doing these projects, pushing them out, and having this forced project oriented class easily did the most for getting a hands on programming, understanding like how to go about and write things and actually ship something, how to test. Um, Plus, then later he taught software engineering 1, 2, and management, which of course helped that even more. Um, but sort of this forced mindset of build projects, build projects, build projects, build projects. Here's how you build a good project. Now go do it. Um, that is really what made the biggest difference, I think, to me. I
Hmm.
didn't read a lot of books. Like, I'll tell anyone, like, I have this giant conglomerate of programming books. Like, there's design patterns over here, there's the Transformers book over here. I've read actually none of those books so far. I have them on my to get to if I feel the need to go read them. Like, this design patterns book probably will be my next one, just because we might be doing it in the study group next. I don't know. We got to make that poll still. But reading didn't really help me a whole lot. Reading
Hmm.
specific things did. Reading specific books that we were assigned in the class to read. But it, programming is this thing where you can have all the knowledge in the world. But if
Hmm.
you don't know how to build the thing, that
Hmm.
knowledge is kind of worthless, right? There's
Hmm.
interfaces now like ChatGPT that can help with it, but in order to be better at programming, you need to get better at programming, and the way you do that is by programming. It's learning a language. Literally, that's why they call them programming languages.
I love it. I love it. So essentially, build a lot of stuff, write a lot of code, read a lot of code. That's the recipe.
Yep, and for people that are like, well, okay, no one's going to read it. Oh, why do I do this? Why do I even make it public? People are just going to bash my code. Oh God, what do I do? The mantra that I tend to do with everything, and this existed from the start, it helped a lot whenever I was doing like Fast AI and writing my courses and writing my study groups for it. Don't write for other people. Be selfish. You are writing for yourself. And then if
Hmm.
other people benefit from it, that's a secondary effect. That just happens to be the case. Like 90% of the courses and study groups and things that I did were all just my notes that I wrote, and people happened to like it. So I was like, well, okay, this seems important. Let's actually teach what's going on because people don't know this. But
No, that's.
Write the thing for
That's
yourself. Write it for no one else. Write it for yourself, by yourself, to teach yourself.
That's exactly
Oh.
how it works. That's one book, Still Like an Artist, but this guy, Austin Kleon,
Mm-hmm.
he has a series of books, and there's another book, sort of Keep Going, but in between these two, and I don't have the book with me right now, but it's essentially what you said, that, you know, the surest way to maybe take part in the whole community of people sharing code, sharing stuff, is you just write stuff for yourself as you learn, and then share it, and maybe people will find it interesting, right? And that's how it works. The motivation can be, like you mentioned, for yourself. Uh, no, sorry for the
Oh
jump into
no.
those books, but
No,
essentially, I also feel very very strongly about that. That, if you're saying that you don't have anything to share, that's not true. Because you've obviously learned something this week, learned something last week, and what you mentioned with people being afraid that others will bash their code, that rarely happens. It nearly never happens, because either you write something that people are interested in, and this is such a rare occurrence to happen, or or no one cares, right? So that has been my experience. But Zach, you mentioned study groups, so
Mhm.
that's also a way to learn from you, right?
Yeah, ish. As someone that has taught a course, led study groups, well, taught multiple courses, led multiple study groups, literally is leading a study group right now. I don't learn from study groups well.
You don't, because your
No,
mind works in a different way, or
it
in
doesn't
like
help me.
all our
Yeah.
minds. Yes, like
Yep.
I also have some ways that work for me, some that don't. I'm a visual learner, for example, so I learn from images but not from hearing stuff. But
Mhm.
many people attend those study groups, and they speak very highly of them. uh,
Yep.
do you have to pay for them, or how does that work?
No, so usually they're free. If you're
Hmm.
paying for them, it better be a good person. And generally how the study group goes is you have a leader. That leader will bring you through a guided discussion over some topic, whatever you want to do. If it's a paper reading group, then you'll talk about a paper. In the case of my reading groups, we'll talk about the chunk of chapters that we were assigned to read that week or weeks, depending on time between. And then if there's open discussion to talk about the ideas, you can. Otherwise, the leader in some ways can teach about it, or someone else can if they have an idea to do. Um, which sort of to backpedal slightly, I don't do study groups well as a participant,
Yes.
but I do study groups really well as a leader.
Cool.
And if you really want to get good at something, start a study group and lead the study group, right? Because it's one
Oh.
thing to show up, right? People show up to the study group, and it's if you saw an engagement chart of like my reading group, it was literally like first day, like 40 to
Mhm.
50 people finish the book, and there's like 3 of us.
Yes.
But that's
That's
not
how
what
it is
matters.
always. Hmm.
That's not what matters, because you're right. That's how it's always going to be. Your
Yes.
retention, as they call it in the YouTube area, your retention graph throughout the course is just going to plummet.
Yes.
Um, so if people aren't going to benefit from this, right? Because you're going to lose people all the time. Why do it?
Hmm.
Well, if you can teach it to them, force yourself to think from a teacher's perspective and learn what you have to learn, you'll come out even stronger. Right? I
Yes.
don't do good as a participant because I want to go do the thing. I don't want someone to like tell me how to do the thing. I want to go do the thing and then solidify my knowledge in it by teaching someone else how to go do it.
Yes.
That's literally this whole thing with my career with Fast AI, Hugging Face, and everything started from that. It was
Hmm.
notes as I was teaching, as I was learning Fast AI and programming Python, to starting a study group with two other individuals at the university, into an online study group, and then those notes from the study group became my course notes, and then those course notes became you know, 2 more courses afterwards. Um, so it's a snowball effect, because if you get really good at being able to teach people what you learned, as I mentioned before, you've solidified your knowledge, you've enhanced your public speaking skills, because now, people can you're forced to make sure that people can understand what you're saying, grasp it, and then like fully ingest what's going on and learn everything they needed to. And now you're more confident to go learn unknown things, because you've also taught yourself how to learn, right? You learned
Hmm.
how to learn by doing that, because you had to learn, a chunk of a chapter over the course of a week, because you know that you're going to be teaching it to other people.
Hmm.
And that's like the other kind of spoken but unspoken area of success, where people are like, yeah, grind, do the hard work. This is part of it. Because if you can get really good at this, everything else is suddenly a lot easier, right? Presenting projects is a lot easier because you've had to teach things. Writing documentation is a lot easier because you've forced yourself to have to explain things to other people. What is writing documentation? It's not writing documentation for yourself, it's writing documentation for other people. And so it sort
Yes.
of starts this train of thought of, okay, other people are going to take what I say and learn from it. How do I make sure that's permanently ingrained in everything I do?
Zach, this is so good. This is so good. This is such a, I mean, this is sort of a secret that's in plain sight, but so many people don't see it, and you have to really experience it yourself, that you only learn by teaching others. And this brings a completely different motivation to all those side projects, right? Like, you're not doing this to become world famous, and you're not doing this to, gain followers or whatnot. The main motivation is you're doing it for yourself, right? So that you can learn, and so that others can benefit as well. Because um, using the machine learning parlance, there's a bit of knowledge distillation happening. I feel that today I'm very grateful that you agreed to talk to me. But in talking to you, I'm also learning, from your perspective, from your experience, and you're validating some of my experience, and I'm looking at different takes on situations. There's this aspect also that is also very important. And to that end, we've already discussed those study groups, but how can people join? How can people, I don't know, jump on a call and listen to you? Where does all the good stuff happen?
So my personal study groups happen in my Discord. Um,
Discord, okay. I'll
yeah,
link to the
Discord is
Discord as well. I will
perfect.
link to the
Thank you.
Discord from the notes below the video.
Perfect. Thank you. I appreciate that. Yeah,
No,
Discord
no.
is kind of where everything happens nowadays. Um, doesn't usually happen on Slack groups. It's all on Discord, I've noticed.
Aye,
Like
aye,
the
aye.
Hugging Face Discord has regular like reading groups for papers. Um, we have a regular reading group now. Before it was just like study groups for the course and just writing projects. Find a Discord group, and the other way is uh like meetup.com.
Mhm.
If you can't find an online group to do it, right? You don't have a big Twitter following, you don't have any Discord friends that you can talk to, you don't have a community that you can reach out to for your particular thing, just go to meetup.com and like just start a local meetup for something. Make it online if you want. And
Cool.
if no one shows up, great. Use that as practice to teach yourself, right? And even if no one comes, okay, make the
Yeah.
content, still publish the content, do everything the same, and eventually someone will come. Is kind of this philosophy that I like to think about,
No, it's a great
because
philosophy. Yes.
it the whole build it and they will come, right? They will come immediately, and it might not be noticeable at first, but they will come, right? I've built as I mentioned earlier, hundreds of repositories of things. Once in a blue moon, like my repository from 3 years ago will get an issue opened of someone asking a question, right?
Hmm.
I built the thing with the assumption that no one is ever going to read that. I went through and looked at
Yes.
that code and went, "Oh, I want to delete this thing. This is, it's a marker of where I was in time." But I'm embarrassed that that was a thing. But everyone's been there. Um,
Absolutely.
but eventually, like people will come and do that, and at the end of the day, even if they don't, as with everything I do it for your future self,
Hmm.
right? So even if you're teaching it just to yourself, you're practicing, your speaking skills to yourself. You still did the research and learned something. And great. Now, no one's there for the hour that you scheduled. Go relax or something. You did the
Yeah.
prep work, you ready to talk. No one's there. Fine. Then reward yourself for, doing the good thing. Don't just sit there in frustration and be like, no one's showing up. Why is this worth doing? Because at the end of the day, you doing what you just did makes you smarter than a majority of the other people doing that thing because they've never looked into it,
Yes.
right?
Yes. 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 No, this is beyond true. This is so good, Zach. Yes, and on top of that, many people say that they're afraid of the reception, right? What will people think? And I'm experiencing this the same thing myself. Like I'm okay with writing things, but saying
Mm-hmm.
things and this whole video thing, it's not easy for me. And there's some emotional hurdles that I need to overcome. But everyone experiences this, and on one hand they would love their stuff to take off immediately, but then they're sort of uh, depriving themselves of this very useful period of time where no one cares, no one sees what they're doing, and they get to practice.
Yep.
So, and like, I don't know, unless you're a psychopath, sharing your code will be tough. Talking online will be tough. Writing out your thoughts will be tough because it feels weird to share your emotions like that, to share what you've learned. So use this time and uh, like you mentioned, I don't care, you don't care, we don't care if our stuff gets traction immediately. It doesn't matter. We can't even predict that. Like I had the weirdest repositories, reach whatever amount of stars that I would never predict myself that this would happen. And yeah, no, this is great. So, Zach, the best place to find you in terms of the study groups is your Discord, right? But
Yep. Discord, and probably keep an eye on me on Twitter.
on Twitter, okay.
Yep.
Discord, Twitter. You also opened up recently your Walk with Fast AI course, Redux,
Yes.
right? The Walk with Fast AI 2, right? That
Yep.
thing.
Yeah. Yeah. I decided that the course I made last year, a year before last, I just recently decided to open source its content, so you don't have to pay. You can go learn, everything that I've learned about Fast AI for the last what 4 or 5 years that I was doing it when I wrote that
Yeah,
course.
Zach,
Yeah, so that's
so tell
an
me about this. Tell me about this. Yeah, that's one
sure.
other thing I would like to ask you. Your
Yeah.
timeline as a developer. Like you went to
Oh,
college, I think they call it in United States, and you wanted to study marine biology, right? For the longest time.
oh, yeah. We can do this story. It's a fun one.
Well, and
Sure.
the reason I'm asking is, you talk about advanced things and making those libraries work together at Hugging Face, so maybe people will think, maybe he has 20 years of experience. He just looks so young and good, and, you
For
know.
the record, I'm 26. First of all,
Oh, personal
I was
details.
coding
Okay.
since I was 6. Can't you tell?
You were coding since yes, that must have been the
Well,
thing. But
yes and no. Yeah,
I,
I can,
huh?
I guess, give you sort of what that timeline was like.
Yes,
So,
please. And coding since you were six, I sometimes run into those people who were coding since they were six. And I wished I was one of those people. But I myself started to code when I was 30, so 4 years in front of you. Still, that maybe dates me too much for our audience
It's fine.
liking. But so Zach, yes, how did this happen? How did you end up in this beautiful world of code?
So, I mean, I've talked about like starting in college. If I'm being honest, started before that.
Okay.
When I was a kid, my dad started me out on like Scratch, and I probably cumulatively over like the 12 years I was a child did like 3 hours of that. Um,
Uh-huh.
but
Just
then I
like my
did
kids.
Lego. Then I did
Just
Lego
like my
Mindstorms
kids.
for a bit.
Oh,
Yeah,
okay.
you're. Oh boy. Um,
Wait,
no.
so is there a coding component to Lego Mindstorms?
Yeah, Lego
Really?
Mindstorms is raw robotics.
Wow.
So they have like a GUI for you to go and like sort of in the way that Scratch works, you can like bring blocks up and that'll move the motor. And so you can program
Wow.
it sort of this way.
Hmm?
And then I think when I was like 13 or 12, my dad got me this Lego Mindstorms book that was how to control Lego Mindstorms with Java.
Java.
I spent maybe 2 days on it and then threw that book into the farthest corner of my room and vowed to never do coding again for the rest of my life.
Yes, I can imagine. That's a very healthy reaction.
Yep. So now that we have that background, we're like, I have some abstract knowledge of coding.
Uh-huh.
In about seventh grade, I decided I want to be a marine biologist. And then I went to college for marine biology, literally working from like seventh grade until 12th grade, learning fish names, trying to literally breed fish in my basement to like become a captive breeder for like
Uh-huh.
clownfish, for like Nemo and other endangered species like that. And then I got to college, and what's the best way I can put this? The marine biology courses punched me in the face very hard.
They
I guess
slapped
would
you
be
with a
one way to
fish.
put it.
They
Yes.
slapped you with a fish,
They
So,
beat me to a pulp, and sort of the conclusion I came to was my drive for marine biology was not as high as overcoming the learning difficulties I had
so wait, it was just
in the
challenging.
major.
It was
Mhm.
just
Oh,
challenging, and
yeah.
so you picked deep learning because obviously, you know.
So we'll get to that. Because I hear you. So what I learned from that is I did fairly well in chemistry and I did good in physics, and I had promised my dad that if marine biology didn't work, I was going to do programming because
Uh-huh.
he knew it was a safe way,
Yeah,
for me to have a
obviously.
career. And of course, he was right. But I then, you know, what I recently talked to a friend about this.
Hmm.
Um, I got to where I was because after I failed out of marine biology, it basically became this life or death situation.
Hmm.
I have to be good at whatever I do next because that is the only thing I have to write on.
Hmm.
So I started learning programming. At the time, it wasn't called software design and development. I think I started in typical CS for about a semester. And then my advisor came to me and was like, hey, I know you were like iffy on physics. Here's a CS route that takes no physics. Do
Hmm.
you want to do it? Me. Yes, absolutely. Give it, please. Like, let me avoid physics. I don't want to do math. I just want to code.
Hmm.
I just want to tinker with things. And so I started in this program that had you start in C++ and then learn Java. About a year in, um, my dad showed me this course that he recommended that I go learn because it was doing cool tech and some really neat things, and he was thoroughly enjoying it and thought it was going to be the next big thing, and it was a big thing at the time. I was
What
like,
course was that?
uh, Fast AI course, the second one, the
Second
second
one.
version of the
Okay.
course. And of course, me, I'm like, Dad, I'm already trying to survive coding and a new major. Why the hell do you want me to go learn deep learning? I'm not a math person. What is wrong with you? So, I told him, like, no, I'm not interested. And then the following year, I think like 6 months after Course V3 came out, I started working in the library.
Mhm.
And I was getting my coding projects done fairly quickly, right? Things were going fairly
Mhm.
well. I'm an analytical person. Funnily enough, analytical projects don't take very long. Uh, and so what kind of wound up happening is I took the first lesson, and then from then on, how my life was basically dictated is 6 a.m. was the gym, 6 a.m. to like 8, and then 8 o'clock to 4 was classes, and then 4 to 7 was homework, plus the weekend if I needed it. But I worked the library at night, and that was like
Mhm.
6 or 7 p.m. until 2 o'clock in the morning. So 3 times a week when I had my shifts, because it's the library, I worked on the floor where we had 3D printers. Everyone up there knows what you're doing. You're never asked for questions. And so I just taught myself deep learning. So by day I was learning how to program, learning these concepts, and by night I was taking Jeremy's Practical Deep Learning for Coders, the third edition,
Mhm.
learning how to do deep learning. Um, and that grind never stopped all of college. Um, Eventually, I would take the night shift to the library because it was like free time where I was forced to stay awake, so I had to do something. And eventually, I was like running. I was the vice president for the machine learning club for a bit. Ran study groups. Did code competitions along the way. Research, regular
But
courses, of course, on top of school.
mhm.
And very thankful that I was lucky enough to basically have paid study time.
Yes, that helps a lot in
And
life.
yes,
Absolutely.
so
The
God, I'm sitting here
life hack
today
that
going, how did I do these things?
the life hack that many people don't tell you. But yes, I also had a similar point in my life. I was, in my early 30s where I could also study. But Zach, so that wasn't that long ago. It was 2018, 2019, right? When you were doing that course, something like
Yeah,
that.
it was I think it was 2019, and then I
Yeah.
graduated college about 2022. So it was,
So,
3 years of my life with an extreme grind.
and you probably started to program seriously, like, for schoolwork around in 2018. That's what we're
Yeah,
looking
I'd
at.
say about, yeah,
So
2018.
that would be 5 years ago. 5 years ago, probably.
It's 2024, Radek.
Ah, yeah, the what?
Six.
11 days. 11 days. Yes, let's
It's
do
been
it.
2024
6 years
for 11 days.
for
Oh
11
no, we've
days.
told people when
Yes.
we recorded this. Yeah, so it's about, yeah, I'd say 6 years, 7 years.
6 years. So 7 years. Okay. All right. So what happened when you graduated from college? You graduated with a degree in computer science, right?
Yeah,
Or
software
software
design.
design.
So that's things get a bit weird there.
Hmm.
So typical route is people graduate and then they go find a job. I graduated and had a job because I was already working my job while in school, teaching fast
Oh,
AI and learning and machine learning and all of this nonsense.
wait a sec.
Um,
So how did that happen? Because a lot of people are always curious. Hey, how do you get a job in software development or machine learning? And what
the community,
at that community? Yes. So
literally.
how did that happen for you?
So I was posting, everything I was doing on the Fast AI forums. Um, I was being active on there and saying my experiments. Oh, hey, I learned this thing. Hey, here's my notes on this. And then Matthew Teschke over at what is now Accenture Federal reached out to
Hmm.
me and was like, "Hey, you seem like a good fit. Do you want to do an internship with us?" And so I did a summer
Hmm.
internship. This would have been junior year, I think.
Hmm.
So no, that would have been ooh. I went sophomore year. I did the internship. It would have been summer of sophomore year because it was right when COVID hit. And then yeah, because junior year I was basically like COVID was everywhere. So then junior year I started working for them. They allowed me to stay on, and I was working part time. And so I was working, doing school, and doing everything. And
So what
then
were you doing there? Like, what were your responsibilities? Were you writing code or what was
they
that?
started me off as a researcher. So I was just
Researcher.
tinkering with machine learning models, and
Yeah,
then
just
eventually,
just a normal thing. In your junior year, you become a researcher, thanks to
totally.
the power of the community.
And then I was leading one of their open source libraries. I took over
Mhm,
because the main developer left. Um, it was an NLP based library, and I worked on that for about a year. And then at that point, I was kind of like, okay, federal stuff isn't quite my vibe. Um, all of my machine learning heroes are currently working at Hugging Face. I'll go throw my application in. So I started conversations there. Mind you, it's still like I am still in school, right? We are
mhm.
now at senior year.
Senior.
Throw my application in, talk to Lysander, talk to Sylvan, do some interviews. Sylvan gave me a heart attack during my coding question
How did he
because
do it? What did he ask you
um
about?
so that's a story I always love talking about. So mind you, I'm nervous as heck, right? Because Sylvan is
Uh-huh.
like one of my heroes, right? Him and
Of
Jeremy are
course,
both like my machine learning heroes.
of course,
They
of
taught me
course.
everything I know.
Yes.
And he was
Uh-huh.
my interviewee.
Mhm,
And so we had a coding problem, sent it to him, uh, documented it all with like NBDev. Solution was okay. I
mhm,
knew it had issues, though. It
mhm,
was not perfect, and the guidelines were just get as far as you can.
mhm,
And so I sent back the solution. I'm like, hey, you said don't work over X amount of hours on this. Here's as far as I got. About an hour later, I get an email back from Sylvan going, hey, normally this is fine, but there's a bug in your code. You
mm,
can either spend 30 minutes on me with me in a one-on-one call or spend an hour trying to solve it.
mhm,
And I'm like,
mhm.
okay, this is the man whose first interaction I have with is grilling my first ever FastDI IPR. And now he's grilling my interview and saying there's a bug in my code. Oh my goodness gracious me. Okay. Um,
Mhm,
so then sent back the code, found the bug immediately, of course. The second, you're saying, well, okay, I know the bug exists, you find it magically.
mhm.
Sent it back, and then started working, I think my last semester of school is when I started. Either that or it was shortly before my last semester because my anniversary date is on my birthday. So it was, yeah, that would have been about 3 months before I graduated. I started working there.
So we're looking at 2020 or
Yep.
2021, 2020,
22.
22.
Yeah.
Right, because
Because I
it's your
wound up
senior
like,
year.
yeah,
Yes, 2022.
ish.
Wow,
It might be two.
wow.
Time's weird. It's either 21 or 22.
Yeah, well, one of those. Yes, no, that's
Now it's 2024. That's
mm,
messing everything up. But I
absolutely
think it's 21.
21, 21. And you've been working with Sylvan on Accelerate for a while.
Yeah. He left the company a few months back now, but before then, for the greater part of like a year and a half, I basically worked with him as my direct boss and
Hmm.
coworker. So it was kind of him and I tackling Accelerate. And then we brought on Sorab, who's done a phenomenal job with Deep Speed and FSDP, and now PEFT, and doing so many cool things. And then we brought on Mark, first as an intern, then on full time, who's doing a phenomenal job with big model inference and everything with that. And sort of, seeing the team grow has been quite a blessing.
And someone is a lead now of that team, so I heard.
Yes. Yeah. Now
Congrats.
recently, I am now the tech lead. So
Huge
it's
congrats.
thank you. Uh, very wild. Now that you've forced me to think about my entire career and realize it's been 6 years, but it's fine.
No, like it's not about the what is it? It's not the number of days in your life. It's the life in your days sort of scenario, because you've obviously been doing a lot over these 6 years, and
Mhm.
probably while doing those things, it didn't feel like a lot, but if you look back, it sort of adds up to
Oh,
quite
trust me,
a
it's
quite a track record.
I have learned it's a lot. Sort of a dirty little secret that I haven't really
Hmm.
talked to a lot of people about. So I tried doing a third course recently. I wanted to do a course on sort of software design practices.
Hmm.
I got about 2 weeks into it
Hmm.
and realized I can't do that anymore. I
Hmm.
can't work, have a life, and write a course all at the same time. That's not possible anymore. Um, it was in college. It is not anymore.
Yes, no, that's a very wise and useful realization, right? Our
Mhm.
situation changes over time, and we sort of it's still amazing that I feel that you've used up the opportunity and the time that you had, in college to an extreme extent, and you sort of try to make do with what you have, right? Um,
Literally, like when I started working at Hugging Face, I think was the first time I owned a GPU.
mhm,
Straight up. Everything else was
mhm.
like free and collab and relying on Kaggle and everything. It's it. You don't need a lot. You just need to start doing something
Yes, yes.
at the end of the day.
For the longest time when I was starting out, I didn't have a GPU, like really for the longest time.
Mhm.
And back then it was quite tough because really the only provider was AWS that had decent prices. But
Mhm.
whenever you would shut down your instance, your everything on the hard drive would disappear because that's how it was
Oh
set up back
goodness.
then. So yeah, it was. But yeah, you absolutely don't need a lot. And right now with Kaggle and with Colab, those are amazing resources and access to GPUs. It's just crazy. So Zach, before I let you go, and thank you so much for this conversation. Like it has been
Yeah.
super valuable. I feel will be to many people, and certainly has been to me. So thank you so much
Mhm.
for that. But maybe if I can ask you one more question from a
Sure. And now we're going to
slightly
add another
different.
30, 40 minutes.
Yeah, yeah, absolutely, absolutely. Why
No, what's
not?
up?
But this will be tangential to your maybe software development experience. But you've mentioned that in college you were doing gym, and on
Hmm.
your Twitter feed, it seems that you're doing weightlifting.
Hmm.
So why is that? Out of all the possible sports, what's cool about that? Like, should others pick it up? What do you reckon?
Oh, Radek, we just add another 40 minutes.
Let's go. Let's go.
So
Let's do it.
I started lifting before I was in college.
Hmm.
With just the way things were, I was always active when I was young. I was playing like baseball and everything, and then tennis. But for a variety of reasons, realized that I didn't enjoy not being able to like do certain things that when you can lift some weight allows you to do. And so I started going to the gym because I wanted to gain a little muscle. And then my senior year of high school, I met my now best friend, and him and I bonded on anime. I think, if I remember correctly. No, we had an argument in debate class on DC versus Marvel. That's what it was. Very on point with all the DC stuff in my background. and he was into lifting, I was into lifting, and so we used lifting as a way to like just talk about things if we don't have anything else to do. And he's been my personal coach for the last like since high school basically. And before I did it to just like, stay healthy, right? Stay physically healthy. But the second the pandemic hit, a stark realization I had is the gym no longer was okay. I need to make sure that, I'm not getting chunky, I'm physically active, and I'm fit. The gym has a profound effect on your mental health. Um, and so I, like a madman, some would say, wake up at 5:30 every morning, bike to the gym, lift for an hour to 2 hours, and bike home to
Every
start my
day,
day.
not like
Um,
once a week. We're talking literally.
no,
Uh,
five days a week. Sometimes six, depending on the program. I'm curious if I quickly log a fake workout here. How many workouts it says that I have done at this point? Let's find out.
uh-huh.
I have done 635 workouts on this app alone.
Okay.
At this point.
Wow.
And the reason I do this is twofold, right? So the first one,
Mm-hmm.
obviously, right, stay fit, stay active. I want to make sure that when I grow older, I can, still have my baby cousins, climb all over me because one of them's a gymnast, and I can like do things with him that I could do right now because he's a little young. The other half of that is 90% of my tough problems get solved at the gym
Mm-hmm.
when I'm lifting weights because when you're there, right, you're focusing on this one movement, just getting in and you're doing it. And so that is the only thing in your head. Well, the other things are still floating. And so usually what'll happen is as I'm lifting, I'll have a eureka moment about some problem I had. And
Yes.
so I use it almost as a meditation
Mm-hmm.
to think about problems that I've had, be it work or life. Um, and on top of that, it's a good healthy habit. You
Mm-hmm.
know, it's great. What is working out going to do if you suddenly become addicted to it or like it's a negative habit for you? You're going to be lifting, you're going to be healthy, you'll be a bit strong, and as long as your like diet's okay, it's just a net positive. Um and it's now sort of become a key part in my day to day as well as like what I would call my sort of okay mode where I can judge like, oh, am I doing okay? Have I gone to the gym? Right? Because if you're coding, it's very easy to get focused on the code, shove your emotions to the side, but then also get frustrated at the code.
Mm-hmm.
But I can trust myself and go, well, okay, did I do the gym today yet? I haven't done the gym today yet. We're probably not okay. Let's go take a walk. Um, it's a mental health regulator, is the word that I want.
I
And
love
I
it.
believe there's been studies about this
Mm-hmm.
where intense lifting releases endorphins that help deal with stress and anxiety, as well as can help with focus. Especially with
Mm-hmm.
me being on the neurodivergent side, there has been studies that show that, which is why I typically do it in the beginning of my day. Um, and so that's sort of why this need for the gym has become a need. Like
Mm-hmm.
working out is no longer like, yeah, let's go work out. Like I need to work out during the week for me to be okay because it is the foundation of what makes everything else work.
I love it. I love it. And what you said about solving problems and eureka moments. So we have two modes of thinking: focused and diffused. And the focused activity is, yeah, when we focus our conscious mind and try to solve a problem. But it turns out that for creativity and for finding solutions that maybe might be uh, more dispersed in our mind, in our areas of the experience that we've accumulated, or more creative, essentially, we need this diffused mode of thinking. So you're focused on the activity, but your brain in the background is doing the real creative work. And many people, many inventors, they were able, or artists, they were able to produce the works that they were able to because they found something that works in their life to sort of tap into this diffused mode of thinking. So that is super valuable, and people went about this in various ways, like, taking naps but not really naps, or Einstein had his violin, right? And so wow, it's so cool that you found a point in your life, or a period of time every day that sort of let your mind work on that. For me, it's driving the car or taking the shower where most of my eureka moments happen. But obviously, yours are much better. And the other thing that you mentioned is how you look at the day, and if you've been to the gym, you know that it is a good day, sort of. So, like, I myself struggle a little bit sometimes. I go through the day and maybe whatever I tried at work didn't work out, and then how do I feel about my day, right? How do I say whether this was a good day that I lived through? And you have this very, very nice measure that you can sort of reach out for, and that is completely under your control, where you view it as a valuable activity, and you can reflect on the day and say that, hey, this is a good day because I've done X.
Yes, kind of. Some days at the gym are terrible. And terrible days at the gym lead to terrible days.
Oh no.
There are some, like, but the core part of, yes, like, did I go to the gym? Okay, it's still a little better. The other thing that I have found invaluable in helping with my imposter syndrome, as well as, like, just beating myself up, is, and I can't recall who said this. You should never compare yourself to anyone else except yourself, because everyone else has a different story, right? You have a hint into mine with what you've learned, right, with this conversation that I've been having with you, Radek. But you don't know my full life story. You don't know everything
Yeah,
about me.
of
You don't know
course.
exactly what I've read. You don't know
Of
exactly what I
course.
programmed. But on top of that, so what do you compare yourself to? Because you should still compare yourself. Compare yourself to yourself yesterday.
Mm-hmm.
And if you're doing slightly better or the same than you were yesterday, that's enough. If you're doing a little worse, then think about yourself 3 years ago. It's a local minima in terms of your performance and how you're doing, but you have this huge traction of, yes, I've been doing great. So now you set your expectation of, well, I need to always perform here because this is when I was doing really good. No, that's how you're going to beat yourself up. Go to 3 years ago. Are you doing better than you were here? Odds are probably yes. So that's still okay, right? You're not meant to work at 100% efficiency all the time. We are not robots.
Yes, that's
We
a
are
great
human
point.
beings. And more than anyone else's words, the words that you say to yourself are the ones that matter the most, because you are in relative complete control over what those say. So strive to be kind to yourself and forgiving, because otherwise you're going to be frustrated, you're going to want to quit early, you're not going to be able to rely on just yourself, you're going to have to rely on other people, and if those people aren't there, suddenly it falls apart. So set yourself up to where, like, okay, I'm not doing the best today, my imposter syndrome is terrible, I don't know why I have this job. Well, you have evidence of this, right? You're working your job right now, you've been here for XYZ long, you know you're doing good, you're not a robot. Some days are bad. Accept the bad day, don't continue working, let yourself rest, and then go do better tomorrow. Because now also tomorrow's standard's a little easier because today was terrible. Um
Love it.
That's something that I've definitely focused on in the last few years, especially after graduating college. Because in college, right, you're surrounded by everyone. Everyone's motivated. Everyone's trying to, get good grades, get that job, get that internship. And the second you leave, you're on your own. And so I had to sort of come to terms with, well, we're really going to have to get self motivated here. And I don't want to be miserable. I prefer having a happy life, or at least as close to happy as I can get. So, what steps can I take to do that?
Mhm.
Tangent done.
S- Stealing those thoughts from you as best as I can, and yeah, it's amazing to be able to tap into some of your thoughts and ideas and wisdom, and yeah, it's there's a lot of experience in those 26 years of yours,
Thank you.
And yeah, I'm just super happy that we can chat today, that we can chat on other occasions, and that is a great privilege, my friends. So grateful for that.
I'm grateful for
Um,
being your friend. It's been phenomenal to be able to just talk with you, chat. It's been
this
phenomenal.
is this has been life changing, and it's it all really started, on a whole new level once we met in person, right? So that's
Hmm.
the Fast AI and conference.
Yes.
So to anyone who's listening, if you're part of a community and you're doing XYZ, maybe after a couple of years, it's a good moment to meet somewhere, even informally, because that makes
Yep.
a world of the difference.
Human beings
Uh,
are not meant to just interact behind screens.
yes,
Human beings are, we started in villages, if we want to go to that old nomenclature, but like, you have your village. Your village is, your community. Go visit them in person.
yes,
Physically see them, physically touch them, and hang out. Grab a beer if that's your thing. But, it makes a difference. It definitely does.
absolutely, absolutely. Zach, thank you so much for this. And if I
Thank you
may
so much
please
for
ask
this.
you, if I may please ask you, so people can find you on your Discord, people
Yep.
can find you on Twitter,
Yep.
and you also post recordings of your study sessions to your YouTube channel.
Yep.
So these
Yes,
three
indeed.
things, I'll link to those from the notes. Zach, thank you for an unbelievable conversation, and
Of course.
yeah, we'll stay in touch. I hope that maybe in a while we can talk again and share some of your thoughts with the broader audience, because this is awesome. Thank you so much, my
Yeah,
friend.
I'd love to. You never, ever, ever ignore a call from Radek. You drop everything and you say, yeah, okay, I'm here. Let's do it. I don't know what's going on, but it's going to be great.
Thank you. Thank you. Thank you. So we are all set. We are all set.
Perfect.
Did you do gym today?
Oh, yeah. Oh,
Okay.
yeah.
Okay.
It,
So it's
it
a
was
good day in
terrible.
your life.
It
It
was
was terrible.
it was a terrible. No, yesterday was terrible. Today was okay.
Today was okay.
Um, yeah, it involved like kind of walking along a highway due
Walking along a
to
highway. Uh-huh.
my car had to go to the shop,
Oh,
and
okay.
I wanted
Okay.
to walk from the shop to the gym
Okay.
instead
Got
of
it.
getting a ride to the gym. That was my own
Right.
decisions, but it led to an interesting day.
Yes, yes, yes. I can imagine. I can imagine.
But
So,
yep, it did, and then I'll be getting up at 5:30 in the morning tomorrow and doing legs, I think.
I like that. Wow, that's a lot. That's a lot to
Yeah,
deal with. All right, my friends. So I won't be holding you up any longer. Please have a good night's sleep, and we'll see you here soon.
sounds good. Thanks, Radek.
Thank you so much.